Hello all, and welcome to the Upper Oconee Science and Policy Summit. I'm Kyle. I'm a graduate student at the University of Georgia, and today I'll be talking about some of the ongoing work we're doing regarding on-site wastewater treatment systems and sewer conveyance infrastructure here in Athens-Clarke County, Georgia. And before we begin, this project really would not be possible without the financial, technical, and logistical help that we've received from the Upper Oconee Watershed Network and River Basin Center at the University of Georgia. In addition, we'd also like to acknowledge the substantial effort that the Athens-Clarke County Unified Government has put into building and maintaining the dataset that I will be talking about later in this presentation. To begin, in Georgia, over 9,000 miles of our streams and rivers are listed as impaired and not meeting their designated uses. Of those 9,000 miles, about 5,000 miles are listed due to some degree of fecal coliform pollution. That makes it the leading cause of impairment in the state. And while we know that poultry and livestock operations can be significant sources of this type of pollution, failing and poorly implemented wastewater sewer conveyance and on-site wastewater treatment systems can also be a significant source of this pollution, especially in urban and developing semi-urban watersheds. And that's because these are imperfect systems. We generally trust that they're doing their jobs to convey or treat wastewater. However, we only notice when acute failures arise. In fact, the U.S. Army Corps of Engineers and EPA have estimated that 75% of the U.S.'s wastewater sewer conveyance infrastructure is likely functioning at 50% capacity or less due to rainfall-derived infiltration and inflow, blockages, or structural failures. Likewise, septic system failures, though they're highly variable, have been shown to be dependent on site conditions, installation methods, maintenance intervals, use, and system age. Fortunately, in Athens-Clarke County, we have a pretty amazing data set of georeferenced on-site wastewater treatment systems, and if you've seen Dr. Capps' presentation already, you already know a little bit about the ongoing and past efforts of building, maintaining, and verifying this data set. In this way, Athens-Clarke County Municipal and Unified Government already has far more information than most local governments regarding the status of their on-site wastewater treatment systems. In this project, we'll be adding septic system pumping information to that spatial data set using septic system pumping manifests that the county has on hand. From these manifests, an example of what you see on your screen, we can get the date, location, and amount of sludge that was pumped per system. This additional information puts the county in a unique position to determine several possible drivers of septic pumping behavior and inferred failures of those systems. In this project, we'll be combining several datasets, including publicly available landscape data, such as land cover and elevation, county infrastructure layers, including septic system point locations and sewer lines, state and local regulatory water quality data, community science data collected by the Upper Oconee Watershed Network, and lastly, the on-site wastewater treatment pumping events from the manifests. So, for the first part of this study, we will be looking at the spatial attributes of the central sewer system in Athens-Clarke County. As I've mentioned, leaking sanitary pipes can be sources of nutrient and pathogen pollution if they go unfixed for a period of time. Likewise, if those failing pipes are near stormwater infrastructure, then those pollutants can be conveyed directly into our waterways. To capture some of these relationships, we'll be calculating and exploring several spatial variables for each of these infrastructure layers and exploring how they may relate to water quality patterns. In these analyses, we'll be combining both community science and state regulatory water quality data, And by coalescing these two data sources, we get pretty good coverage of water quality in the county over space and time. To that environmental data, we will be adding our county infrastructure data, with which we will be exploring water quality patterns as they may relate to the spatial attributes of those infrastructure layers. And for the second portion of the study, we'll be looking at the attributes of septic systems in the county. Namely, we'll be quantifying the soil suitability, slope, and distance to stream for each of the septic system points. And in doing so, we will explore the relationships between the physical septic system site characteristics and the county level pumping records that we have in order to isolate the site attributes of locations that have pumping records that are indicative of failing systems, or as I've coined here, red flag pumping intervals. Likewise, we will look at tank age and explore if tank age is a good predictor of those same red flag pumping intervals. Specifically, some of these pumping intervals that are indicative of failing systems include those which have pumping events more frequently than the EPA guidelines of every 3 to 5 years, septic systems that are continually being pumped following rainfall events, if a record indicates that the pumping volume exceeds the actual tank capacity, and lastly, if a pumping event occurs and then the system is subsequently replaced within a year after that event. And lastly, we'll make a comparative analysis between those watersheds that are primarily serviced by central sewer versus those that have on-site septic systems by comparing the long-term water quality means in those watersheds. In conclusion, fecal coliform pollution is the leading cause of stream and river impairment in the state of Georgia. Failing sewer and septic systems are likely contributing to this problem in urban and developing peri-urban watersheds. Athens-Clarke County has a very unique data set, and through its analysis, we may be able to provide insights into how, when, and why these infrastructure systems fail to perform adequately. And finally, it's our hope that these findings can be used to prioritize infrastructure improvement investments and guide future environmental monitoring efforts in the county and elsewhere. And we encourage you to reach out if you have feedback, questions, or information regarding this research, or if you're interested in future collaborations. I hope you learned something. Thanks for watching, and have a great day.